some background about what forensics is. The word forensics comes from the Latin word forensis, which means to the forum in regards to a court of law. Forensic science investigations are used in court to prove innocence or guilt to a suspect. Forensic science investigations rarely hold the power to convict an individual solely based on its findings, but almost always work to exonerate misidentified individuals. As of April 12, 2019, 365 people have been exonerated from findings in forensic science investigations here in the United States. Organizations such as the Innocence Project work to free wrongly convicted criminals. This organization was founded in 1992 by Peter Newfield and Mary Sheck at the Cordozo School of Law. So why I decided to create a forensic science kit was because I'm really interested in studying the human body and studying DNA. This summer, I took a class on DNA sequencing and the genomic revolution, and this just deepened my interest into studying DNA. This was a way to tie together my passion for biology and criminology while I could not study the actual human body in a high school setting due to health and safety rules. My project is a forensic science kit with 6 template DNA samples where you identify the suspect using results from a gel electrophoresis. In real investigations, you would never have 2 identical DNA analysis results except for identical twins because these are the only humans who share identical DNA. This kit could potentially be included in biology or honors molecular biology curriculums here at Bullis. I created this kit because most high schools do not teach their students about forensics. This led me to create my problem statement, which is high school students need a way to engage in forensic science experiments because most high schools do not expose their students to forensic sciences. In my preliminary research, I found that some public schools do have a forensic science class, but in particular, Bullis does not have a class for it. This would benefit students to have exposure before entering college about forensics to see if forensics is something they would want to pursue a major in. As I developed this kit, I encountered a lot of successes and a lot of challenges. I streaked out over 10 strands, which were all prepared over 20 years ago, and have since been stored in a negative 80 degrees Celsius freezer. After I streaked out my strands onto agar plates, I conducted the flame method, which prepares DNA cultures. I then mini-prepped the DNA to purify the DNA away from other cell components, conducted PCR, which is polymerase chain reaction, and then conducted gel electrophoresis. I would run my template DNA through PCR to make more copies, and then run the samples through a gel to compare the lengths. PCR is conducted in real forensic science experiments to amplify DNA when there is too little DNA or the original DNA is too degraded to be analyzed. In my kit, there would be a gel which includes 8 wells. 6 of the wells would be template DNA samples which would represent your suspects. The 7th well is your evidence well, which is a repeat of one of your 6 suspects. Your suspect is found to be present at the crime when their DNA matches up to that of the evidence well. The 8th well would be a kilobase ladder to compare the length of the fragments. Here you can see a video of what gel electrophoresis looks like. And as you see, there will be bands occurring throughout the different wells here, and those are all different lengths. As you can see in the video, sometimes the DNA well will have multiple bands because DNA can be nicked, supercoiled, or linear. Supercoiled DNA occurs because DNA must be very tightly compact to fit inside a cell. Supercoiled DNA is the way DNA wraps around itself to fit millions of base pairs into one tiny cell. Nicked DNA can occur from when enzymes cutting the DNA have an isolated area where your typical double-stranded helix is cut and separated into 2 individual strands only for one section. Linear DNA is your typical double-stranded helix, and you can see how long the band is of that strand. However, all the different types of DNA can be compared against the kilobase ladder to see how long it is. PCR results. On the picture on the left, you can see the kilobase ladder here. Below is DTB 185, 186, 729, and 738. Here on the right, from top to bottom, you have DTB 185, 186 is not present. There's 729 and 738. Here is my kilobase ladder, which you use to compare the lengths. Below is 711, 871, which is not present, and 889. The strands that I will use for my kit are DTB 185, 186, 729, 738, 711, and 889. The reason that 186 and 871 could have not worked in my second PCR test is there could have been an error in preparation, such as not actually getting the template DNA into the tubes. The size gets down to less than 1 microliter, so it can be very difficult to see if all your sample actually exits the pipette. As you can see here, these are the size of the vials in comparison to crushed ice. So you can probably imagine how difficult it is to see what is actually entering them. And then these vials go into the thermocycler, which then amplifies the DNA. When I first started out developing this kit, my goal was to have 8 samples, but I was only able to create 6. However, I learned how to purify DNA and conduct many different procedures within the lab. I started off with basic procedures, such as stripping out the strands of the agar plates, and progressed into procedures to amplify and analyze DNA. This project has confirmed my interest as forensic science as a future job interest, and has led me to continue my studies at the University of Miami, where I was studying with microbiology and criminology to put me on a path for a forensics job in the future. Thank you.